All right, let's just jump right in. I mean, you've seen it, right? Over the last couple of years, things like ChatGPT have just exploded. All of a sudden, AI isn't some far-off sci-fi thing anymore. It's right here, writing our emails, helping us plan trips, and totally shaking up how we work. But what's really going on under the hood?
And we're not just talking about a little upgrade here. You'll hear experts call this a step change, which is a fancy way of saying it's a massive leap forward in what AI can do. We are literally watching a transformation happen in real time, and boy, is it moving fast.
So let's get past the hype for a second. What are these things really? How does the system go from a simple question you type in a box to a complex, creative, and sometimes startlingly human answer? Well, that's exactly what we're going to break down.
To really get it, you have to understand that this isn't just about making a better chatbot. This is a fundamental change in the entire philosophy of how we build AI. And it all kicks off with this key idea, the foundation model.
Now, this isn't just some marketing buzzword somebody cooked up. The name actually comes from researchers at Stanford. They saw that the whole AI field was starting to move in this one new, powerful direction and realized the old way of doing things was pretty much on its way out.
And this really nails the difference. Think about it. The old way, if you wanted an AI to, say, check if a review is positive and another one to translate German, you had to build two totally separate one-trick pony models. But now, with foundation models, it's a whole new ballgame. You build one single, massive, powerful base model, and then you can teach it or adapt it to do all of those things and way more. It's like going from a team of hyper-specialists to one single genius who can learn pretty much anything.
Okay, so if one model can do all that, how in the world does it work? I know it feels like magic, but the basic idea behind it is surprisingly simple. The scale is what's complicated, but the core trick? Let's pull back that curtain.
So at its core, a foundation model is a type of generative AI. And the name really says it all. Its whole purpose is to generate new stuff. It's not just finding information that's already out there. It's actually creating brand new text or images or even computer code by learning the patterns from a mind-boggling amount of data.
So where does it get this superpower? Simple. Data. A truly ridiculous amount of it. We're talking terabytes and terabytes of what's called unstructured data. All that means is it's messy, raw information, not neatly organized in a spreadsheet. Basically, think of it as the model reading a huge chunk of the internet. Books, articles, websites, you name it. That huge chaotic library is what gives it such a broad understanding of our world.
And this right here is the perfect way to understand its core function. When you strip everything else away, the model is basically just playing a very, very sophisticated game of guess the next word. It looks at a sentence, and based on the billions of patterns it learned from all that data, it just predicts the most probable word to come next. And when you string thousands of those little predictions together, one after another, poof, you get a paragraph, an essay, or a poem. That's the generative magic, right there.
Now, having a general-purpose genius is great, but how do we get to do something specific for us? Well, there are two main ways. First, there's tuning. You can think of this like sending the model to grad school. You take that big general model and you give it a little extra training on a smaller specialized data set, like a bunch of legal documents, to make it an expert in that one area. The second way, and this is the one you've probably used, is prompting. This is just talking to it. You ask it a question in plain English, like, hey, summarize this article for me. The model then uses all its general knowledge to figure out exactly what you want and
So this technology is obviously incredibly powerful. But with great power comes, well, some pretty big challenges. This is no silver bullet, and it's super important that we understand the trade-offs we're making. This table really lays it all out, the good and the bad. On the one hand, the advantages are just wow. The performance is incredible. Because these models have seen so much data, they can do things older AIs couldn't even dream of. And the productivity boost, it's huge, because you're not starting from scratch every time. But, and this is a big but, the flip side is pretty serious. The cost to build and run these things is astronomical. And then there's the whole trustworthiness problem. Can you really rely on what it says? That's a massive challenge we're all grappling with.
And let's just linger on that cost for a second. We're not talking about something you can run on your gaming PC. Training one of these models requires giant data centers, filled with specialized computer chips, running full tilt for weeks, even months. This creates a massive barrier, right? It means only a handful of huge companies really have the resources to build these things from the ground up.
And that trustworthiness issue is no joke. Think about it. If you train your model on the wild, unfiltered internet, it's going to learn the good, the bad, and the ugly. It can pick up biases, misinformation, all sorts of junk.
And what makes it even harder is that these things can be a black box. For a lot of these models, we don't even have a clear list of what data went into them, which makes it almost impossible to predict or fix these problems ahead of time.
You know, we've been talking a lot about language, mostly because that's what everyone knows from things like ChatGPT. But it is so important to realize that this whole foundation model idea, it's about way more than just words. It's being applied to all kinds of different fields.
I mean, just look at this list. You've got vision models like DALL-E that can create a beautiful image just from you describing it. You have coding assistants like Copilot that are fundamentally changing how people write software. But it's also pushing into deep science. We're talking about AI and chemistry, helping to design new medicines, and models for climate change that help us better understand our planet. The core idea is exactly the same every time. Train a huge model on a ton of data, then adapt it to solve new, interesting problems.
So this technology is spreading like wildfire, and it's touching so many important parts of our lives. Which, of course, brings us to the big question, what now? Where do we go from here? If the first wave was all about building for raw power, the next wave has to be about building for responsibility.
And that's exactly what's happening. The whole focus of the research community is shifting to tackle those big disadvantages we just talked about. The new race is to make these models more efficient, to make them more transparent so we know why they make certain decisions, and to make them way more reliable so we can actually trust them with important stuff in business, science, and health.
And that right there is really what this all boils down to. The power of this tech? It's undeniable. The potential is absolutely immense. But as we rocket forward, the real challenge isn't just about making these models bigger or faster. No, it's about making them better, making them safer, more reliable, and making sure they actually align with what we as humans want. So the biggest question we're left with isn't, can we build this stuff? It's, how are we going to make sure we build it right?